highest business in the worldwide market. Their shares are very, very high among all the companies. Why? Because they have done innovation in the area of graphic cards. Now all GPUs, their products are going in all the graphical processing units because they have done innovation, in their product portfolio. However, Intel, many of you must have heard about Intel layoff many engineers because their product line is not that much defined over the years. They have also jumped very late into the graphic card business or neural processor business or AI processor business. They were thinking that we have the foundry, we have the fab labs. Fab labs means where the IC used to be manufactured. That is called the factories. Right? So they have strong belief that somehow the desktop business or the laptop business will never ever die. But over the innovation, right, what happens? That big machines are going to be miniaturized. And now very strong processors are sitting in your smartphones. Strong processors are sitting in the smartphones. So why somebody will use the big desktop, big laptops, right? So that is what the invention comes and innovation comes, right? So in the semiconductor business also, right, if people will not improve their performance matrix, that is the power consumption, speed, right, AI capability into the chips and so on and so forth, you will be out of the market. And people will not love to buy those products. So in the similar line, people are trying, and the processor is the, among the processor, right, there is a CPU, or you can say computer architecture, there is a CPU, there is the brain of the machine, right? Then the memory also, volatile, non-volatile memories, right? And then lots of things. So memory used to be always the integral component, always in the huge demand, right? Either the primary storage or secondary storage. So in the computer organization, probably you may have learned in the BTech first year, right? The how computer organization used to be there. We have the primary memory, then secondary memory, hard disk drive. Many of you must have. Nowadays, SSD, that is solid state drives, right? And then the cache memory, which is sitting very close to processor. Then the DRAMs, and the same, and so on and so forth. So when you go and buy the mobile phone or something, what we used to ask, कितना storage देगा भाई, right? 256 GB वाला लेना है आपको, 512 लेना है, 1 TB लेना है, keep asking, right? Why? Because you want to store movies, you want to run heavy programs, programming and so on and so forth, right? Everywhere we need storage element, right? At the same time, you want a memory which is called the cache memory, which is very close to the processor, right? Which act as a kind of milkman का आता है, क्या करता है? एक बड़ा सा दूध का बकेट रखता है, हम लोग घरों में उससे बकेट ले अपना बर्तन लेके जाते हैं दूध लेने, राइट? तो क्या करता है? उसके बाद एक मग्गा होता है छोटा सा, मग्गा क्या करता है? बड़े वाले बास्केट में से निकालता है, आपके मदर को देते रहता है, राइट? तो 1 लीटर दूध चाहिए तो एक बार दे देगा या 2 बार डालेगा, अगर हाफ केजी का उसके पास मग्गा है तो. That is the Java SRAM. SRAM is sitting very close to the processor. तो प्रोसेसर और मेमोरी के बीच में जो सेकेंडरी मेमोरी के बीच में फास्ट कम्युनिकेशन करता है, that is SRAM. सिंपल है. तो आपको मेमोरी डिजाइन करने के लिए we need a high speed, and that is what SRAM, static random access memory, which is one of its kind, which is sitting very close to the processor, right? Similarly, resistive random access memory, and this is the magnetic random access memory. So these two falls under non-volatile storage. So what is non-volatile storage? Volatile memory, non-volatile memory. अब बताइए आपके फोन में सब मेमोरी कैसे है, non-volatile है कि volatile है? Volatile. एक बार डेटा हो गया तो स्टोर रहेगा, पावर चला जाए तो भी कोई टेंशन नहीं, राइट? और volatile में क्या है? पावर ऑफ हुआ तो डेटा क्या है? So all the this image and everything, audio, video is stored where? Non-volatile memories. थोड़ा आपको कंप्यूटर एनिमेशन आना चाहिए, right? Otherwise it will be. Now, so we are working on different dimensions. Now this is the another area called the photonic memory. So what will happen in the future, right? Where let us say one data center is sitting here. Let us say one data center is IT park, right? वहाँ पे बहुत सारे सर्वर लगाए हुए हैं. एक कंपनी का नाम आपने सुना है, नीम क्लाउड्स, रैक बैंक. रैक बैंक आपके इंदौर में ही एक डेटा सेंटर की कंपनी है, and who host lots of data of different companies. तो उनका सर्वर है बहुत सारे, राइट? वहाँ पे आपके सबके डेटा रख सकते हैं. दूसरा सा अमेज़न सर्वर का नाम सुना होगा ना, Azure and so on and so forth. What these are the data center companies जहाँ पे आपका डेटा वहाँ स्टोर होता है जाके, राइट? सो nowadays अभी एक डेटा सेंटर इंदौर में हमारे लिए, एक चेन्नई में है, एक पुणे में है. Now we are in our country, we are also developing the data centers. Okay, this is a big business. एक तो बिजनेस है कि पर बिट आपके कॉस्ट क्या है. तो अगर आपका डेटा यूएस में सेटअप होगा तो आपके पूरा डेटा एक तो यूएस में जाता होगा. जो भी हम लोग गूगल वगैरह पे स्टोर करते हैं, ऑल द डेटा यूज्ड टू गो टू द यूनाइटेड स्टेट्स सर्वर्स. तो आपका डेटा एक तो सुरक्षित नहीं है, बिकॉज दैट डेटा इज नॉट अवेलेबल इन आवर कंट्री. वंस दे विल स्टॉप और दे कैन ruin your entire country. And hence for the national security reason, the country is also looking for own data center. खुद का डेटा आपके देश में रहना चाहिए, नहीं तो क्या होगा? Every data, whatever confidential work we are doing, it used to go to United States. So now photonic means what? Where the light will travel. अभी जो भी आपके पास product है, where all the electronic chips are there. All the chips are electronic chips. Where electron used to travel in our semiconductor devices, either processor, memory, controller, whatever you are thinking. Small devices which are going to be placed, even all the electronic gadgets, electrical gadgets. But now, for the future quantum computing or quantum chips, right, we need kind of media where rather electrons, the photon used to travel. And hence the speed is very, very high. So now the future generation computing called the quantum computings, we need a device called the photonic device, जहाँ पे light travel करे. और अगर light travel करेगा तो उसकी speed बहुत ज़्यादा, very, very high, right? So if you want to send the data from one data center to the other data center, which is let us say 1,000 kilometers away, so what will happen? You need to send the data very fast through the optical fiber communication systems, right? So there is an interface chip, because आपका जो सर्वर है वहाँ तो इलेक्ट्रॉनिक चिप्स है ना, लेकिन आपको एक ऐसा बीच में इलेक्ट्रॉनिक चिप चाहिए होगा which will be the combination of electronic chip as well as photonic chips, which can pass the signal, electronic signal, to the photonic signal. At the same time, people are looking for in Stanford and MIT, they have already developed the photonic processors. At the same time, photonic accelerators. So not only storage element, at the same time with lots of storage element, how to process the data and how to compute the data, so that next generation computing system में आपके chip लग सके. At the same time, we have also talked about the cryogenic memory. So what is happening in the cryogenic memory? जो भी आपके chip लगे हैं, जिस भी electronic product में, इसका एक temperature range है कि भाई प्लस से एक सर्टेन माइनस तक ही ये सस्टेन कर सकता है चीज. बट इन द कमिंग ईयर्स, लुकिंग द क्वांटम मिशन, क्वांटम चिप्स इन द कंट्री, आपको कोई भी डिवाइस डेवलप करना है तो दैट डिवाइस शुड वर्क एट 4 डिग्री केल्विन, एंड हेंस द क्वांटम चिप्स इज सपोज्ड टू बी देयर. सो अभी आप लोग जैसे डायोड पढ़े होंगे ना, डायोड सबने डायोड पढ़ा होगा. अब डायोड को जब आप आईवी कैरेक्टरिस्टिक्स प्लॉट करते हैं तो दैट इज फिक्स्ड ऑन ए टेम्परेचर, फिक्स्ड टेम्परेचर. बट उसी कैरेक्टरिस्टिक्स को आपको अगर निकले, मैं बताऊं मैं आपको 4 डिग्री केल्विन पे करना है, which is minus minus very minus, right? So how the device will behave? So in the country, our country also, people are trying to design and develop the cryogenic memories, cryogenic computings, or you can say quantum chips, which is going to be the next year generation computing systems. So जो आप लोग डिवाइस पढ़ते हैं, बीजेटी पढ़े होंगे ना सबने, बीजेटी पढ़े होंगे, डायोड पढ़े होंगे, मॉसफेट भी शायद पढ़े होंगे, राइट? अब आपको सोचना चाहिए, सर से पूछना चाहिए सवाल कि कोई भी कैरेक्टरिस्टिक्स आप प्लॉट करते हैं कि बहुत लो टेम्परेचर पे वो कैसे बिहेव करेगा. सो प्रोबेबली यू आर द थिंकर You are the next generation scientist who has to always think कि इसके बाद क्या होगा. इसको low temperature में करोगे तो electrons how they will behave, and then how you can realize those things into the storage as well as computing. Okay, so the new area where many people are talking and trying to develop the cryogenic memory, cryogenic circuits, cryogenic processes. Alright? So likewise, we are also trying to learn with the different students, different research groups here and there. But yes. So here, like many people talking about the von Neumann computer architecture, where processor is there, memory is there, right? But nowadays, this is the bottleneck. This is the problem, right? So people are trying to do the computing into the memory itself. No need to have any processing or something. That is called in-memory computing. In-memory computing, or you can say compute in memory. There also compute and memory can be of two kinds, either with the volatile memory or non-volatile memory. So with all the AI chips, artificial intelligence chips, right? We are trying to have different sort of memory, either volatile or non-volatile. Then we also try to design the peripheral circuits and so on and so forth. So probably I will not go in detail today, otherwise you will be confused. Now the other area where people have started talking about the AI accelerators. So whatever performance metrics are there, like for example, compute efficiency. So all the parameters which I am going to talk later is going to be measured by some numbers. So how to achieve that numbers, right? These we are dealing with these small accelerators, cards. So nowadays these cards are going to be placed in the GPUs, so that the performance of that GPU machine is going to be very, very high. But now these chips, inside chips which are sitting in the cards, they are going to be designed using in-memory computing. Right? And that we call it the AI hardware accelerator. There also either you can low processing or high processing flexibility, that we'll discuss later. Photonic memories, which is more than Morse. So Morse was the scientist who was one of the Intel founder in 1960 or something. He has given a prediction, a kind of law at that time. The number of transistors are going to be every year double, right? Something like that. So, but now no more valid Moore's law. With the advancement of materials, with the advance of devices, with the advancement of equipment, and so on and so forth. Right? So beyond Moore's, these photonic chips are going to be the next generation computing systems. And of course the security, because hardware security and the business. If you are having a computing system, either mobile processor or desktop processor or anything, without security, because everywhere you are dealing the data, and if somebody breach the data, your hardware will fail. So earlier people are talking about the software security, but now in the hardware itself, in the chip itself, they are going to put a couple of algorithms, or you can say the logics, which will protect your data. So on the software level, people are putting, but now all the chips are going to be more safe and secure. So that design strategy people are putting, and we are also putting. So this is the small introduction about the PDK, so called the process design kit. So when you are thinking to design a small logics, for example, a kind of adder, let us go with that adder. Full adder, everyone knows, right? So what we do in the lab, probably you may have used some ICs in the BTech first and second year, or let us say counter, 4-bit counter. So what you have done, you have used some chips where logic gets sitting, and then you may have connected with the wires, powered by some power source, some voltage, and then you are just trying to see the behavior whether it's working or not, right? So that is the discrete chips and discrete devices based systems. But in the IC, everything is going to be integrated. So what is an IC? IC stands for integrated circuits. What it used to have? It used to have all the active components as well as passive components. Resistor, capacitor, and so on. So BJT, MOSFET, and so on. So basically, when you wish to design any chips, any processor, any memories, any controller, any sort of components, then we have to have some PDK. And these PDK will used to have certain guidelines, and these PDK is given to us as a circuit designer from these foundries. So these are the foundries, or you can say the chip fabrication facilities across the globe, who used to provide us some PDK, and as a chip designer, these are the EDA vendors. Cadence, they used to give us the softwares where these PDK used to be inserted, which are available for the particular technology node. So when I am saying let us focus about TSMC. How many people have heard about TSMC? Taiwan Semiconductor Manufacturing Corporation. This is the company located in Taiwan who used to manufacture the chip across the globe, more than 90% chips across the globe. Like NVIDIA chips, right? All the even Qualcomm chips, right? They are the only who are the pioneer in the worldwide. Right? So TSMC does. So accordingly, they used to offer the technology node. Latest technology is 2 nanometer technology node. Do they have the equipments and the factories? So what we do as a circuit designer is sitting in Bangalore, Hyderabad, Pune. What we do? We just design the chips sitting on the computers and these softwares. Either digital chips or analog chips or RF chips or whatever based on your expertise. So whatever knowledge you have learned, you used to design, right? So these are the tools. Synopsys is very popular, Xilinx and Cadence and so on and so forth. And these PDK we obtained from these foundries. So for example, this is SCL. This is the only fab in country now which is commercial fab called the SCL in Mohali. Alright. So the technology which India had 180 nanometer. How much? 180 nanometer. And what is the current trend in the commercial product? 2 nanometer is very low. But 7 nanometer processor. If you check your processor, Qualcomm processor, Snapdragon, is 7 nanometer FinFET technology. When you go, you check. So there they have written 7 nanometer Qualcomm Snapdragon processor. It means 7 nanometer is the minimum dimensions, right, which is utilized to design the logics or the circuit and the system in your mobile processors, right? So in India, this technology is 1 nanometer, but this is available to any students, any professors across the country, any industries, any startups, free of cost. But even Samsung, which comes from the South Korea, even there, nobody can find the free of cost facility. But last couple of years, the government of India has opened these foundries, SCL foundry, free of cost. You can design the chips, not only foundry, but these softwares are also, and very fortunately, your institute is a part of it. So here also, we have all tools available free of cost. Cadence, unlimited version, unlimited license. Unlimited license, unlimited license. So any student who wishes to design, they can contact two professors here or their seniors. You can design the chips, sitting in your laboratory on the computers, and finally once design completed and meet the requirement of the design, then you can send designs to SCL even at 180 nanometer, and your chip will come out to you in the 4th year of your degree program. Right? So you can contact similarly United Microelectronic Corporation, then STM Ecosystems, IHP Germany, Global Foundries, many foundries, IBM, Intel, many foundries are there, Siltera, many foundries, and every foundry has their expertise. For example, some foundries are very good in silicon, some foundries are very good in silicon gallium nitride or gallium arsenide or silicon carbide chips for EV chips, right? EV transistor. The EV transistor is not working at 5 volt, they are working at 200 volt. Or some companies are working the photonic chips or photonic IPs. So they have their different assembly lines. Right? So in India, here, this is the silicon chip. And some MEMS and other chips they can fabricate. Right? So like now they are running this gallium nitride one line also they are putting up. So, right? So gallium nitride is for electric vehicle chips, or you can say electric vehicle components. So like that is the one where you should learn. Coming to the other things which are available in the country is of course the IEEE. So you may have also IEEE section here in the institute. So IEEE Circuit and System Society is the one where we are pushing our people in the state of Madhya Pradesh to be the part of the Chip Initiative program. Then there is another society called E&I Society of India. So in this year, they have launched a program called One Tops. One tap out per student. So this program says that if any student across the country wishes to send the design not in Indian 180 but 55 nanometer technology with the global foundries GF. In the span of 4-year program, your BTech program, right? In second year, third year, fourth year, whenever you wish, the VLSI Society of India will take care of all the charges with little money to the institutes, but you need not to worry. So you can be the part of this program, right? And you can send your design and you can get the fabricated chips in your hand. So coming to the real topic which I wanted to touch upon, right? For example, the autonomous drone, right? Everywhere these smart chips are sitting, right? Or you can say city surveillance systems with the smart, this and the humanoid and number system, detection system, and so on and so forth. Everywhere, either big machines should be there, but you cannot place the big GPUs on the drone. You cannot, right? Otherwise, drone will fall down. So you are looking for a kind of tiny chips, small tiny chips, either in the form of 2-inch class 2-inch or 1-inch class 1-inch, which can be mounted on this city surveillance system or a humanoid and here and there, which can compute or which can process the data, whatever data you are trying to send from the sensor node. Right? So that is what this the AI hardware accelerator is. So you have a tiny chip having a huge capabilities to deal the AI workload data, either image or audio or text or video, whatever, right? So you have to design your chip so strong that it can process the heavy AI workload. Right? But traditionally, all the chips which we used to design, right, early days, it was not having AI capabilities. Right? So this probably help you to understand how big market of AI is. Right? So if you go from 2023 to 2029 data, right, then you will find that this market is going to be $312 billion or something, huge market, right? So it means that will help you and motivate you that now probably you have to thinking about the AI hardwares, AI chips, simple AI, right? Because the market is very high, and that too from across the country, across the globe. Coming to, these are the performance metrics which I was talking about, right? So the first performance matrix, which is compute performance, right? So compute performance used to be measured with the help of tera operation per second, right? You may have heard about what is GOPS, right? Giga operation per second, tera operation, or sometimes tera floating point operation per second. Means your hardware, which you are talking about, either GPU or AI chips, are that much operation, that much tera operation they are performing in a second. That much compute performance. For example, power consumption. It used to be measured in the watt, right? Memory bandwidth, it used to be measured in the gigabyte per second. So I will give you some example. Let us say that you are talking about the edge AI accelerator categories, and similarly the cloud center or data center compute category. So think about the NVIDIA A100 tensor core chips. Right? They are so strong that the compute performance is 156 teraflops. Right? Similarly, for this Google Cloud GPU version 3, tensor processing with Google they have, right? So they may have, like for example here, the compute performance is 420 TOPS. That much operation they do perform sitting in the GPU or cloud center. Similarly, for the tiny chips, for example, Hollywood, they are the small tiny chips sitting in your processors or here and there. Okay, so they are primarily for the deep learning or for the edge AI application. So their compute performance is 26 TOPS, tera operation per second. It means if you want to process the AI workload in these tiny chips, which is sitting on the edge node, understand edge node and cloud are the two different. Edge means at the edge itself where the sensors are feeding the data. For example, autonomous car, so LiDAR sensors are going to be placed. So the image which you are road image or the side or curve or bump, whatever image are there, that is going to be sensed by the sensor node called LIDAR sensors. It used to compute by these accelerators, which is placed on the edge itself, called the edge devices. But in case the data goes from sensor node to the cloud, which is the servers sitting in the United States or here and there, then what will happen? The latency will be there. So all the strategic application where you are supposed to not send the data from sensor node to the cloud, right? That is all going to float on the drones, future drones, or maybe the humanoid and here and there. Because the time you are looking for immediate decision, the machine has to take the decision right away. You sense the data, process the data, compute the data, take the decision, and go ahead. So all the cars which are going to be autonomous car, which are already there in the market, Tesla and so on and so forth companies, so what they are all having edge AI processors, edge AI computing. They are not sending, because otherwise what will happen? The data will go to the sitting millisecond fraction even, and then only it will take the break. The bumper is coming, so it has to take immediately, right? You cannot wait. So the edge AI processor or edge AI devices having this much capability. Similarly, this other board. So I'm sure that many of you may have used some microcontroller boards, STM32 and so on and so forth. But now you should start thinking, making your embedded system using these boards, where you can dump the complete AI workload data, either in the form of image or audio or video or whatever it is. Okay, so the age has been gone where people were happy with dealing this kind of microcontrollers. Alright. So think about these boards and their, for example, the memory band. Bandwidth is 40 gigabyte per second. It's very high. How to achieve this kind of memory band? So in case you wish to design this AI on the accelerators at the edge or at the cloud, okay. So what should be the range of the market products? So the Google one, they have this much range, right? NVIDIA, they have this much range. Similarly, this Helio board, they have this much range. So when you try to design some AI accelerators at the edge, either in the cloud, we try to meet those parameters, which gives the product, I should say the product parameters. Right? So as a researcher, as a student, probably you cannot achieve even compute performance sometime in a single design 26, because you have to do invention there, right? Because they are the companies. But at least you try to be 10 tops. That was also fine. Right? So as a student, at least you should be aware of how to proceed and how to think about designing these kind of products. So these are all about the, many of you may have learned about neural networks. Neural network? Many of you, right? And many of you may have also learned about various tensor core, Jupyter node, many of you, right? In the Python. So there you will learn about what kind of data sets are there, right? MLST data sets or AlexNet. These are the neural network model. Or these are the CNN. How many people have heard about CNN? Convolutional neural networks. So all kind of even computing systems which are going to deal with the AI, they have different kind of neural network. One is artificial neural network called ANN. The other one is a CNN, convolutional neural network, and the third one is RNN, and so on and so forth. So as a student, don't wait. You start learning the complete computing system from the right away. Don't wait that you will reach in third year and then you will learn the CNN. Then your opportunity will keep. So start learning the advanced technologies, scripting languages. Then these are the LeanNet. This is the first architecture of the CNN. Similarly, the AlexNet, VGGNet, right? These are the neural networks like RusNet, VGGNet, and so on. So GoogleNet. These are the various DNNs called the deep neural networks. And depending upon these data sets of these neural networks, industries as well as academia people used to follow. So the number of parameters used by this one is the academicians we used to follow, right? And these are sometimes optimization, and this one followed by the industries. So Google Brain, NVIDIA networks, right? These are followed by the industries. So if you think about the number of parameters led by the Google Brain is 10 to the power 12, very, very high. That much parameters they are dealing. So you will understand slowly, but I don't want to take into the depth. But over the period of years, you will understand that the GPU performance is used to be 1,000 times than the earlier days. Think about this number of flops operation. So early days, over the period of years, this earlier it was like this, and now with the GPU, 1,000 times in 10 years. That much compute performance people have achieved. Right? Similarly, we have touched many things. But this is the memory, how memory evolved. Energy density of memories per unit, right? Per bits charge, nanojoules. Bits per nanojoules. How much energy is consumed to compute one bit, right? So there, if you think about these different memory architectures, like this is low power DDR and so on and so forth, and this is high bandwidth memory. So nowadays, this is the trend in the memory, and this is the technology node. So this is 90 nanometer, the bigger one, and so on and so forth, 16 nanometer. Even though this is the old data, but the energy efficiency also used to be very, very small over the period of years. So the memory used to be designed in such a way that in case you want to process or compute the AI workload, so what should be the energy? What should be the per bit watt also? Not only energy, but what per bit watt. So it should be consumed very, very less. And hence the cost used to be calculated. So all the data centers which I was talking about, there the revenue used to be generated with the reduction of the cost per bit. And why the data center cost is very costly? Because of the keeping those environments a very cool environment, right? So all the GPU, they used to generate heat, right? So if you wish, you can go to the here IT park, okay? This and you can meet those guys. They have developed a coolant, but the processor are going to be deep inside that coolant. So there is a company called 3M. So 3M comes from the United States. So 3M Materials, they have developed a coolant where these guys are putting the complete server. Why? Because the cost of running the AC inside the data center is very, very high. India, either in Chennai or different part of the coastal area also is very, very costly because the humidity is very high. So now people are thinking of that how we can develop our own data center in the country, okay, and how we can reduce the cost per bit, so that a normal person can also avail the data center in the company, in the India itself. Right? So there you will learn once you will try to understand the market and so on and so forth. Yeah, this is about edge intelligence. So if you are trying, so this is the compute performance, that is the compute efficiency per watt. Right? So the edge devices, this is going to be 10 raised power 3 tops per watt at 1 milliwatt. Right? So basically this kind of trade-off we used to do in the research. Alright. So just quoting the example, this is the GPU chip, right? This is the of H200 and B200. This is the technology node, the number of transistors, how much? 80 billion transistors. Right? And here you get 208, right? So this is the compute performance, this is the memory requirement and so on and so forth of this. So they have developed that much strong GPU chips, right? And these are going to be placed into the GPU rack servers. So this is the typical architecture of a complete AI chips, which used to have the microcontroller or any processor sitting here. These are the external compiler and so on and so forth. This complete one is having its own output memory, and this one is called the processing element. One processing element used to have this MAC unit and processing engine. So this is called the processing engine, one processing engine. So as a student, you have to think, you have to start this journey from here, that this used to how to design the one complete first processing engine, and this is the control engine. So this is the complete AI system on chip architecture, which used to have the processor, external devices, control engines, and these are the processing element. So the one processing element used to have MAC unit and addition and multiplication. That's it. And I am sure in digital electronics you may have learned about addition as well as multiplication. Right? Simple job, nothing to worry, right? But these are the small AI hardware accelerator companies, like lots of designers, right? Design companies. I was talking about Synopsys and Cadence, or fabulous companies, Broadcom, Marvell Semiconductor, Qualcomm, AMD, MediaTek. These are all the designers. Alright? So you may, at least you should be aware that how this complete cycle used to be there in the AI chip market. These are the equipment manufacturer, right? KLA, Lam Research, Applied Material, ASML, then the fab labs, Samsung, Intel, SK Hynix, Micron, TSMC, Texas Instruments. These are the fab units. And these are the packaging units. Once chip fabricate, we have to encapsulate from outside world. So it is the packaging industries, right? And then these are the equipment companies like testing, chemical, wafer, ion implantation, all those things are also needed, right? To complete the complete manufacturing plant. This is a complete manufacturing plant. And hence in the country, you may have learned about Gujarat and Guwahati, right? And then some fabs are coming into the Panvel, Mumbai. So they are the coastal area where we need lots of chemicals, lots of gases, right? And hence these fab labs which are going to be, soon start in the country, they have placed close to coastal areas, right? And similarly chip providers. These are the people who used to provide the only CPUs, AMDs, Intel, Apple, and so on and so forth. And NVIDIA is the highest, which used to provide the GPUs. And these are the guys who used to give the field programmable device. These are the ASIC devices, these are the memory chips. Right? Similarly, these are the end users, where all the chips are going to be placed in the either server side or edge devices. Okay? So this is the complete AI hardware accelerator ecosystems where we need designers. So what designer does? They use the and then the testing chip will fall, yes or no, then they used to be making this product line. And their product line used to be made in the commercial product. Okay. So this is how the chip industry works. What's time, sir? So now these neural networks things, you learn, go back and learn what kind of neural networks history is there, like ANN, CNN, fully connected network, and so on and so forth. Right? So I was talking about one neuron. One neurons, which is going to be the one fundamental units of the any processing element, having the multiplication and addition unit. That's it. So once you know the multiplication and addition, you apply some algorithms and you can apply the activation function, then you can design the complete one neurons. One neurons used to have the MAC unit plus activation function. And these are the different kind of activation functions. So for example, sigmoid, tan, hyperbolic, ReLU, SHILU, GILU, lots of functions are there, right? And these are the multiplication and addition. Multiplication, accumulation units, that's it. Right? So for example, here the inputs are there and these are the synaptic weights. So x1 into w1 gives the xi into wi, and similarly plus x2 plus w2. So basically these weights w1, w2 and so on and so forth, they used to store in the first slide when I talk about the memory. So weights are going to be stored there. And from where these weights comes? Weight comes from the training of the neural networks. What kind of network you are training? On the software, on the processor. So the trained weight will come where you are applying the AI model. So in your AI subjects, if you may have learned in your 12th standard, nowadays 7th class also, there's a book available, a book on the AI. So there you need to understand different kind of neural networks, how it is shown to model, what kind of data sets you are there studying, either image data sets or audio data sets, or which data set you are picking up. Right? So all those things you need to apply, and then you can design the complete MAC unit, and this one MAC unit is going to be stored in a place called, which I was talking about here, processing element. This is the 2D systolic array, means rows and columns. Right? So this is called the complete systolic array, having let us say 128 cross 1. So you have to make this processing element very strong, where the weight and bias come from the training of the data sets, which is called the AI workload. Alright? So all those things, slowly probably you will learn, right? Once you will jump into this domain, right? And then these are the activation functions, the coding of these things also you need to perform, and then you optimize in such a way that the hardware it should be very small. But as a BTech student, you need to understand that what kind of accelerators used to be available in the market. So, for example, you can do the acceleration at GPU. You can also do the acceleration at the ASIC level, which is tiny chips, and each have advantage and disadvantage. For example, the GPU, when you are trying to train the data or accelerate the data at the GPU, so the speed is very high. Right? At the same time, it used to consume more power because rack servers keep consuming more power. Right? At the same time, they used to generate new heat. But here, if you think about this, as tiny chips having capability of AI workload, they used to have the optimum speed. They consume low power, right? And those chips are going to be deployed in humanoid or drones or here and there, or city surveillance systems, right? At the same time, they are not flexible because once chip is in, you cannot do anything, right? So the long time to market because to design the one chip, it takes years and years, okay? And the cost of implementation is also very high, right? But there is one more option where FPGA as an acceleration. So what is FPGA? FPGA is readily available chip where you can do reprogramming. So Intel and many foundries, they have developed their own accelerators or sometimes called as neural processors. Neural processing units called NPU. So they have low throughput, right? But they have the flexibility of the computation, reconfigurable in the nature, and so on and so forth. Because of these very important features of this FPGAs are more preferred for the student point of view as a product designer. So you need to buy the Halio board or some other boards, right, where you can reprogram many times depending upon your application. Simple, right? Sentient is a company. Many companies have developed their own neural processing units board, right? So probably among the students, some boards are very popular, right? So now you should leave all traditional boards, buy those smart boards where you can deal the programming of the AI workload, and then you will learn. So this work I wanted to explain because this work we have done in our lab, where this is my scholar who has taken different images and classification of the images, and then accordingly we have developed this chip. So this probably will take more technical details, which don't want to be discussed here. But as a beginner, right, you try to understand that the complete spectrum is needed like this. I'm telling you here. Here. As a student, you should be smart enough to deal the things on the software level, first software level. So for that, you need to understand the Python, minimum tensor core or PyTorch, whatever you guys are studying in the first and second year, you should be aware about the software level understanding. You need to take the input image in case you are dealing the image as a data set. You can take audio as a data set. You can take your voice as a data set, and so on and so forth. So you need to process, train, and so on and so forth at the software. So from here, you will get the weight. I was talking about the weight values. So the software understanding of hardware is much very needed. Then you need to do on the FPGA first. So all the weight and everything you have to store, and you see whether your chip is going to work or not. Then you do all those things on the ASIC level, which is talking about small tiny chips. Follow all those steps, then test the chips, and then fabricate and do finally result extraction. So as a AI accelerator developer or something, you need to learn the software part as well as hardware part. So for example, this is the computer vision chips, right? Where cameras are there, images are going to be captured, right? And then it will be compare the chips within the chips, and then they used to extract the result. Right? For example, just to give you an example, let us say you make AI chips, right, of the face recognition of these people, 100 people. So what will happen? So all the faces of the images of 100 people will be loaded inside the chips. Let us say that you come next day with the beard chip or something, right? So definitely your face will not available in the hardware, right? So when it compares, definitely they will find that this gentleman is not part of this. That is with the AI chips, but early chips we are not having that capability. So all the AI chips having different image classification. This is the problem of image classification and identification. Of the age also you can do age of all those things, right? So data set creation is another challenge in the country of different kinds, right? So data set creation, then the pre-processing and processing, so and so on and so forth. So when you are trying to enter into the hardware accelerator group, means the semiconductor chip person, you need to understand the data set side, training side, language, and so on and so forth, right? And then of course there is a huge opportunity in this industry, okay? And fortunately, you have everything in your GSITS, you have lots of FPGA boards, you have large number of PDA tools, everything is available here. Right? In your department itself. So आपको कहीं नहीं जाना है, आपको बस सर से मिलना है, काम चालू करना है. So now ये बताइए कि आप लोग 4 साल में ऐसे कितने लोग हैं जो एक चिप बना के जाएंगे? In next 4 years, take up the problem. अभी नहीं, जल्दीबाजी नहीं, आप सोचिएगा आराम से. This is a huge opportunity in the job and placement, right? The software, if you enter into the software industry, is probably not more than 10-20 lakhs rupees, but not everyone. But if we try to enter into this domain, semiconductor domains, Qualcomm, Intel, Texas Instruments, analog devices, top at 20 lakhs, 30 lakhs to BTech guys like you. But you have to do some projects during the next 4 years. थोड़ा थोड़ा प्रोजेक्ट आपको करना पड़ेगा, थोड़ा थोड़ा मेमोरी डिजाइन करिए, प्रोसेसर डिजाइन करिए, आरटीएल में कोड लिखिए, लेआउट बनाइए. आपके बायोडाटा में वो चीज़ दिखना चाहिए, क्योंकि जब तक आपके बायोडाटा में वो दिखेगा नहीं, हाउ यू आर गोइंग टू शॉर्टलिस्ट योर रिज्यूमे. इंडस्ट्री विल नेवर एवर शॉर्टलिस्ट, राइट? तो आपको स्क्रिप्टिंग लैंग्वेज अभी से आना चाहिए. टीसीएल, आई डोंट नो हाउ मेनी पीपल आर लर्निंग स्क्रिप्टिंग लैंग्वेज अभी से पढ़ो. C# या कोई भी लैंग्वेज है पढ़ लीजिए. हार्डवेयर आपके पास है ही, सॉफ्टवेयर है ही इस इंस्टीट्यूट में, सब कर लीजिए. तो कम से कम 4 साल के दौरान छोटे छोटे प्रोजेक्ट कर लीजिए, कॉम्बिनेशनल, सीक्वेंशियल, व्हाटएवर योर प्रोसेसर, मेमोरीज, व्हाटएवर यू विश, राइट? आइदर परफॉर्म ऑन द हार्डवेयर इटसेल्फ. एफपीजीए बोर्ड उठाइए, एआई एक्सेलेरेटर का बोर्ड उठाइए, उसमें डेटा को फीड करिए, ट्रेन करिए, देखिए हुआ कि नहीं, एक्यूरेसी कितना हुआ, ट्रेंड एक्यूरेसी कितना हुआ, राइट? और वेरिएशन एक्यूरेसी कितना हुआ. बट यू कैन थिंक ऑफ टू डेवलप योर ओन प्रोडक्ट आप लोगों को बड़ा मजा आता है जब आपके पास बना बना कोड है. आपको डिजाइन ऐसा कुछ में यू कैन प्ले विद द कोडिंग. But nowadays large number of boards are coming who has the AI capabilities. इसका मतलब ये हुआ उसके अंदर वो ऐसा चिप है जो AI वर्कलोड को संभाल सकता है. तो आप लोग एज ए बीटेक स्टूडेंट यू शुड स्टार्ट जर्नी विद द फर्स्ट प्लेइंग विद द हार्डवेयर. आप एफपीजीए बोर्ड लेके आइए मार्केट से, उसमें डेटा को एंट्री कराइए, उसको प्रोसेस करिए और देखिए वेदर यू आर गेटिंग द सेम कंप्यूटर विजन एप्लीकेशन और नॉट. फॉर एग्जांपल स्मार्ट सिटी सर्वेलेंस सिस्टम बनाइए, नंबर प्लेट डिटेक्शन सिस्टम बनाइए. तो नंबर प्लेट में हमने एग्जांपल दिखा था 1 2 3. सो एजेस यूज्ड टू बी डिटेक्टेड, बट बिफोर एआई प्रोसेसर लाइक व्हाट वाज उसमें दैट वाज नॉट ए कंप्लीट पिक्चर. सो बट विद द एडवांसमेंट ऑफ द एआई चिप्स, with those FPGA boards, if you are playing with that, so your algorithm should be smart and accurate correction and the capturing of the images. Right? So this was we are talking about the kind of image processing or computer vision applications. I say, for example, if you have smart voice recognition systems, right? All kind of natural language processing used to be there. So, for example, if I am saying yes, so probably my pronunciation is something different than yours, right? So in the current information system in the car, it used to voice command. But sometimes you may have experience in your sitting in the car, sometimes you say something and the machine doesn't recognize. Means the processor which is sitting inside the information system on the car, they don't recognize. It means the natural language processing unit which is sitting there, the voice is not coming to them and either they are not understanding and distinguish your bias whether you are there, right? Something. So you can find a variety of application with the advancement of AI technology at the same time with the advancement of semiconductor technology. Alright? So maybe we can take up one or two questions and then I can stop my session. Any questions? Anybody? Any queries? अगर आप में नहीं होगा क्वेरी तो किस में होगा? आप तो you are so special, one of the finest student in the country. I mean, at least in this state. All JEE good scorers sitting here, right? Yes.
Sir, my name is Rashmit Namdev and I am from second year. Sir, my question is that of course we cannot manufacture such chips, but sir, like chip designing using EDA, so sir, how can we start this at primarily level?
Very simple. आप तो सर को कांटेक्ट कर लीजिए, है ना? बहुत सारे स्टूडेंट काम कर रहे हैं यहाँ पे, राइट? और आप वेरिलॉग सीख लीजिए. अगर आपको स्कीमेटिक में इंटरेस्ट नहीं है तो वेरिलॉग इज द लैंग्वेज और सिस्टम वेरिलॉग. सिस्टम वेरिलॉग इज मोर अप्रोप्रिएट फॉर द इंडस्ट्री. तो वेरिलॉग की बजाय आप सिस्टम वेरिलॉग से चालू करिए. फॉर एग्जांपल एडर बनाना है, ठीक है? सिंपल एडर, फुल एडर. फुल एडर में क्या है भाई? सम है, कैरी है, इतना ही, नथिंग है स्पेशल. एएलयू बनाना हुआ तो एएलयू में भी ऐसे होता है, ऑपरेशंस परफॉर्म करेंगे, राइट? उसकी कोडिंग होती है. कोडिंग यू गाइस आर वेरी स्ट्रांग, राइट, इन द कोडिंग. सो इजीली यू कैन डू द कोडिंग. अदरवाइज कई बार कोडिंग उपलब्ध रहता है पहले से, सब कुछ उपलब्ध है, उसको डालना है. देयर इज सम स्टेप्स व्हिच यू हैव टू फॉलो एंड योर चिप विल बी रेडी. इट्स वेरी सिंपल जॉब. But somehow among the students and among even many academic institutions, there's a big fear. Big fear कि अरे यार chip design कैसे होगा? Very very simple. Is it not more than 2 days exercise, which we used to provide. 7 दिन में हम आपको chip बनवा देंगे. सब मॉड्यूल बने रहते हैं, आपके यहाँ भी हैं. आप बस इंटरेस्ट लीजिए, आप अप्रोच करिए प्रोफेसर को, उनके ट्रेनर्स हैं, PhDs हैं, मास्टर्स हैं, वो आपको हेल्प करेंगे. एक बार आपका इंटरेस्ट आएगा, ये तो बहुत सिंपल है, तो आप बड़ा चीज़ भी कर लेंगे, राइट? तो डिज़ाइन के एंट्री मेथड जो होता है, एक तो लैंग्वेज बेस्ड है, वेरिलॉग, सिस्टम वेरिलॉग. किसी भी हार्डवेयर को डिस्क्राइब करने का 2 मेथड. या तो आप लैंग्वेज से उसको ट्रीट करिए, ऐसे एडर को कहा. एडर में क्या होगा? कितने इनपुट वेरिएबल हैं? A, B, C. इनपुट हो गया. आउटपुट क्या आएगा? सम और कैरी. ये सबने पढ़ा होगा. अब उसके लैंग्वेज लिखने के तरीके हैं. आप ऐसे भी लिख सकते हैं कि व्हेन ट्रूथ टेबल बना के जब 0 0 तीनों 0 होंगे तो सम क्या होगा? 0 होगा. कैरी क्या होगा? 0 होगा. सो दैट इज द डिफरेंट क्लास. फिर वहाँ डाटा स्टाइल, स्ट्रक्चरल स्टाइल और बिहेवियर स्टाइल. तो देयर इज ए लैंग्वेज. तो लैंग्वेज आप यूट्यूब पे उपलब्ध है, आराम से पढ़ लीजिए. 10 दिन में आप पूरा लैंग्वेज खत्म कर सकते हैं. फिर बना बनाया कोड रहता है, नेट पे उपलब्ध है, वो डाल दो, चेक करो. सिंपल. सो इट्स अ वेरी वेरी सिंपल फिलॉसफी ऑफ चिप डिज़ाइन. लेकिन धीरे धीरे आपको सेमीकंडक्टर डिवाइस समझ में आना चाहिए, क्योंकि जो प्रेजेंट चिप्स है दे आर ऑल डन बाय द मॉसफेट वन. तो आपने मॉसफेट भी पढ़ रखा होगा आराम से. बस 2 चीज़ चाहिए सेमीकंडक्टर के लिए, मॉसफेट और डिजिटल लॉजिक्स. लॉग आरएफ बाद में पढ़े लेंगे, लेकिन जो जस्ट टू स्टार्ट द जर्नी, अगर आप हल्का सा लैंग्वेज पढ़ लें तो धीरे धीरे आपको इंटरेस्ट आएगा कि चलो अभी आई वाला पार्ट भी करते हैं. ऐसा कोई बड़ा काम नहीं है. आई होप आप लोगों को थोड़ी एनर्जी तो आई होगी. आप सोचे बाद में बोलेंगे, जब पढ़ना चालू करेंगे बोले यार तो प्रोफेसर बता के गया था बहुत सिंपल है, ये तो बहुत कठिन है. पर ऐसा है. आप जब टीम बनाएंगे तो आपकी 2-3 लोगों की टीम बनाओ. डोंट वर्क अलोन. यू डेवलप फ्रेंडशिप विद कंप्यूटर साइंस पीपल, AI, EC, जो भी बच्चे आप लोग हैं, या आप लोग में से किसी का कंप्यूटर बहुत अच्छा होगा, प्रोग्रामिंग किसी का बहुत अच्छा होगा, किसी का डिजिटल लॉजिक बहुत अच्छा होगा. वर्क टुगेदर. एक प्रोजेक्ट ले लीजिए, ALU डिजाइन करना है, सिंपल प्रोजेक्ट ले लीजिए. फुल एडर ले लो यार, दैट इज अ स्मॉल प्रोजेक्ट. यू जस्ट एंटर्ड कि आपने डिजाइन एंड डेवलपमेंट ऑफ फुल एडर. लो पावर मेमोरी डिजाइन किया आपने, लो पावर एडर डिजाइन कर लिया, हाई स्पीड मेमोरी डिजाइन कर लिया. सिंपल सिंपल थोड़ा. ऐसे 4 प्रोजेक्ट आप अपने बायोडाटा में डाल देना. करियर होते होते आपको एनवीडिया, क्वालकॉम इंटर्नशिप ऑफर कर देंगे. वंस यू आर देयर इंटर्नशिप फॉर 2 months or 6 months, they will give you PPU also. PPU stands for रिप्लेसमेंट ऑफ. हो गया काम आपका. 30-40 लाख के आदमी हो गए. प्रोफेसर ऐसे ही है, राइट? जस्ट फन. तो यू आर इन द बेस्ट इंस्टीट्यूट. आप लोगों को तो और तेज काम करना है, बहुत काम करना चाहिए. तो अभी जो भी यहाँ सर क्या ट्रेनिंग वगैरह होता है ना, यहाँ पे फ्रंट एंड डिज़ाइन होगा, बैक एंड डिज़ाइन होगा, आप लोग उसमें पार्टिसिपेट करिए. और एक काम आप लोग कर सकते हैं कि VLSI सोसाइटी ऑफ इंडिया का स्टूडेंट प्रोग्राम चैप्टर चालू करिए आप लोग सबके सहयोग से। वी विल हेल्प यू। एक ग्रुप ऑफ पीपल आप लोग बनिए 5-7 लोग, और आप लोग VLSI लेक्चर चालू कराइए, ठीक है। जैसे मेरा टॉक आज हो गया, कुछ समझ में आया होगा, कल परसों एनवीडिया के किसी को बुलाइए, टेक्सास को बुलाइए, किसी को बुलाइए, तो बुलाते बुलाते में आप लोग वर्कशॉप करिए 7 डेज का। एंड आप लोग जो सीनियर होंगे दे शुड कम फॉरवर्ड एंड गिव यू ट्रेनिंग। रविवार को शनिवार को 2 घंटे का कोर्स करना चाहिए आपको, तो देन यू विल अंडरस्टैंड। सो बेसिकली यू कैन फॉर्म ए क्लब, स्टूडेंट क्लब, चिप डिजाइन क्लब बनाओ, उस क्लब में आप लोग काम करिए। 3rd ईयर में स्टूडेंट विल टीच यू, सेकंड ईयर विल टीच यू फर्स्ट ईयर, एंड सो ऑन सो फोर्थ हो जाएगा। तो ये चीज़ें क्लब में काम करना चाहिए। क्लब मतलब आप वॉलंटियर बेसिस पे कर रहे हो, वहाँ कोई टीचर नहीं आएगा, कोई प्रोफेसर नहीं आएगा, आपको खुद ही पढ़ना और एक दूसरे को ट्रेन करना। तो दैट कल्चर यू कैन डेवलप हियर आल्सो। अदरवाइज वी हैव सम पीपल इन IIT इंदौर, सून वी विल सेंड द स्टूडेंट बॉडी, वो यहाँ आके आपको बताएंगे, करेंगे। आपके पास तो सारा हार्डवेयर सॉफ्टवेयर सब कुछ है यहाँ पे, दिक्कत ही नहीं, आप जंप कर सकते हैं। बट एक चीज़ मैं ढंग से बता दूँ, प्लेसमेंट इस एरिया में बहुत है, सुप्रीम है, सैलरी पैकेज बहुत है, बट मेनी स्टूडेंट दे डोंट नो। एंड फॉर्चुनेटली आपका जो 10-20 साल पुराने सीनियर हैं GSITS के, दे आर होल्डिंग ऑल बिग पोजीशन इन द कंट्री इन सेमीकंडक्टर्स, राइट। सो यू हैव अ ग्लोरियस हिस्ट्री आल्सो व्हिच प्रोबेबली IIT इंदौर डोंट हैव। हमारे बच्चे तो अभी 15 साल पुराने हुए, आपके बच्चे तो 20-30 साल सीनियर हैं लोग, तो उनके पास तो दे आर कंट्री हेड कोई है, कंट्री मैनेजर कोई है अलग अलग कंपनीज में, राइट। वाइस प्रेसिडेंट, प्रेसिडेंट लेवल के लोग हैं, GS, उनको बुलाओ, उनको इंगेज करो। तो ये तो आप लोगों को करना चाहिए ना, स्टूडेंट को करना चाहिए। प्रोफेसर के पास कहाँ टाइम देता है ऐसा करने के? क्लब फॉर्म करो, उनको बुलाओ, ठीक है भाई। और क्वेश्चन, second question, no question, any suggestion, any question from any girls? No? सेमीकंडक्टर इंडस्ट्री में एक और बता दूं, सेमीकंडक्टर इंडस्ट्री में फीमेल्स आर डूइंग वंडरफुल, क्योंकि उनका सीटिंग कैपेबिलिटी बहुत होता है। एंड चिप इंडस्ट्री डिजाइन करने के लिए ना आपको बहुत बैठना पड़ता है। मेल्स तो 1-2 घंटे बैठेंगे, फिर तफरी मारने चले जाते हैं, तो दे आर नॉट द बेस्ट डिजाइनर्स। In Taiwan, if you go Taiwan, Singapore, Malaysia, you will find the best designer females. Right? I'm not discouraging the males, but yeah, this is the truth. चलिए, ठीक है सर। Sometime we will have a workshop, hands-on workshop. जब वो hands-on करेंगे तो आपको मजा आएगा। अभी तो बातों बातों में पता नहीं 10% भी समझ में आएगा कि नहीं आया होगा। जब आप खुद काम करेंगे तो आपको ज़्यादा मजा आएगा।